Welcome everyone. I think it's a good thing if people are standing actually. Like for me this feels good. You know, it seems that there's a lot of interest at least. Yeah, I apologize already for the first error on the slides. Of course today is August 7th. But yeah, I'm sorry about this one. Alright, so yeah, I'll talk about internet scanning just before we get started. Just a brief introduction here. I think this slide is a little bit funny because the Twitter handle over like the last 2-3 years moved up in this list. Like it used to be down there or maybe at the end of the presentation, and nowadays it's just so important you gotta have it on the top. But anyway, so I'm a security researcher at Rapid7, more concretely, more specifically in the labs team. And the labs team yeah, focuses on research and proof of concept development. So we're trying to help out internal product teams, but also doing, a lot of research and development for the community, pushing open source projects, trying to yeah, improve our tools and give you guys something to work with. Just apart from that, I'm also a developer for Cuckoo Sandbox. I hope that some of you have heard of it or maybe used it for some malware analysis, some incident response purposes. So if you have any questions about that, feel free to come to me afterwards. My background is a little bit more research on botnets, malware, so reverse engineering. My first talk was on the Stormworm botnet in 2008. So that's where I a little bit come from. This project's pretty much different, but it's a lot of fun, and I hope I can yeah, deliver that message to you. There are lots of other smaller side projects. If you're interested in Android security, then you might want to check out dexlabs.org, which is one of my projects from last year. Honeypots, developing new data sharing protocols, all sorts of side stuff. All right. So today I want to give a quick recap about internet scanning, like who's doing it, what the purpose for different people is, what kind of our motivation is, and our project, our label basically is called Project Sonar. So I'm giving you a bit of information about that, what it is, what it means, how you can participate, how you can leverage the data or the stuff that we're doing. And yeah, and we do research on our own data. We do research on the stuff that we find out on the internet. And of course, I'm going to tell you a little bit about the findings. There's some good stuff I think lined up. Some vulnerabilities and some problems that we found are still in the disclosure process. So I won't be able to go into the exact detail, but in a couple of weeks, months, it's definitely disclosed. So. Yeah, we'll go into a little bit of a use case at the end. If we have time, this is going to be a pretty tight schedule for 25 minutes, but I'll try to make it quick and not too quick, hopefully. All right, so what are we talking about? We're talking about large-scale data gathering, scanning, internet-wide, basically. So reaching every IPv4 IP address. We're actually in the process of also getting our hands on some data about IPv6 and the services that are available in IPv6. But as most of you know, the classical internet scanning and just enumerating all IP addresses definitely won't work for IPv6. So we have to take a little bit different approach there. So the history of this is quite long. The first internet scanning and reaching every IP address project, sort of, with that outline, with that goal, started in 98 plus something around maybe 2000, I guess. They tried to, with the internet mapping project and also the IPv4 census, they wanted to see how the allocation of IP addresses, is progressing, and see, how much of the net blocks are in use, how many systems are online. And then there were some interesting other projects. The EFF SSL Observatory, I think 2014 is definitely wrong. I think it's 2010, I think, when it was. But it's still ongoing to a certain extent. I mean, the researchers are still there working on the data, but at least it was a 3-month project, I think, and they gathered all available SSL certificates on the internet and all things in use. And they were able to show that there are, misconfigurations, problems with certificate authorities, broken certificates, duplicate name usage around the globe. So it was really definitely interesting. And they shared their data set in raw for researchers to work on. And that was really awesome because everybody could take a look, verify their assumptions, their findings. The Internet Census 2012 was pretty funny. I think some of you will remember this one. Basically, there was a researcher taking over, I think, between 100,000 and 400,000 embedded devices or other systems by basically just trying default passwords or trying, guessing a few passwords. He was able to compromise like, 100K plus machines, but he didn't use it for Bitcoin mining as everybody does nowadays. He just used it for actually performing a scan on, a really high amount of ports on the whole internet. And they published this data, I think it was a torrent, and you could download like the unzipped 9 terabytes of collected data that they had. So it was really interesting. Of course, illegal approach. I mean, compromising devices and using them for your own purpose is of course not legal. But nowadays we're actually able to replicate some of that in a legal way and in a way that is sustainable and doesn't require this sort of practice. Shodan, most of you will know it. Internet search engine, you search for banners, HTTP headers, something, and you will find all the systems that expose or show that particular thing. So RIPE Atlas is slightly different. They spread around like thousands of nodes across the globe and measure timings and bandwidth, not bandwidth actually, but timings, round-trip times between those nodes. A couple of other ones. So Critical I/O was actually the project, kind of the predecessor to what we're doing within Rapid7 today and within the labs team. And basically also try to go out there and see what is necessary, how good does it work to gather data, gather banners and information on the whole internet, a couple of different ports, and do it over the course of maybe half a year. So University of Michigan is a big player nowadays. They're basically responsible for some of the new tools that are released. They released an internet scanning tool, basically the Nmap for like internet-wide data gathering. It's not really a competitor of Nmap, it just serves a different purpose. And this is also something that we use in our project. Shadow Server does something. You might have heard of their publications, their research pages for open recursors, NTP servers that are vulnerable to the monolith thing that was used for denial of service recently. Okay, a couple of other ones, and then there's us with our project Sonar. So just a little bit of the history. Because for us, this has already proven to be very interesting, very useful for research. We found in, I believe it was beginning of last year, right? The UPnP problems, UPnP vulnerabilities. So this was spearheaded by H.D. Moore, and he basically looked at like the internet and his scanning data, and he saw that UPnP is even more widespread than HTTP. More UPnP exposing devices than web servers. And he looked at it, and it turns out that 3 of the major software stacks, making up over 60% of the whole device range, are vulnerable, and they are, compromisable, buffer overflows, that sort of thing. So you could just remotely get code execution on those devices. So this was very good finding. Lots of people started worrying more about that stuff, looked at UPnP, more research was done, and hopefully, we were able to fix a couple of 100,000 devices maybe, or at least lock them down maybe by raising awareness. IPMI was similar. In IPMI, it's a server management protocol. It's used to, if you buy like a 19-inch rack server, then sometimes it comes with this server management protocol. You can use it to reboot the server, reconfigure the system, reconfigure the whole hardware basically. And it had a really nice vulnerability, or like a kind of a misdesign. It used authentication and encryption to protect like the login to this, and you could just turn it off essentially. You could use the standard tool, tell it to say, encryption none, and then it would just let you log in if you know a username. You didn't even have to use the right password. So that was pretty funny. Of course, not funny if you have thousands of these servers around. You need to patch all of them. So yeah, NTP DDoS amplification problems. They're actually used in a big DDoS, I think earlier this year. Was it last year? Earlier this year, I think. And the problems are known, and they were disclosed and published in 2010 already. So, there was like, hey guys, this is a huge problem, we need to do something about it. Nothing happens, and then a few years later, there's a big DDoS, and people, start actually worrying about this. Then there's open recursors, open SMTP relays, spam sources, Elasticsearch instances. I'm going to come back to that a little bit later. But there's basically a lot of stuff out there that is misconfigured, has problems, has vulnerabilities, is unpatched, or people just don't realize what it actually is that they put on the internet. And so this is really what we're trying to point out, raise awareness about, and actually collect data on. Yeah, Mining P's and Q's was a very good paper. I can recommend reading that from the University of Michigan, I think in cooperation with UCSD, that there are a lot of weak keys used in for SSL communication. They found that like 50, 60,000 of certificates actually shared like one of the prime factors in their public key, which makes them, vulnerable. So this is one nice picture that one of my colleagues found, which kind of describes and sums up this whole situation. It's like it's a crazy environment out there. You will find lots of problematic, misconfigured stuff that you don't understand when you look at it first. Like, why is this there? What does this doesn't make any sense. And I'm going to go over a couple of examples that we showed previously or reported, published recently about. So one thing was, for example, SNMP is a protocol also to monitor and manage servers and switches and so on. And it has one feature to list running processes on a device or on a system. And it was funny because it actually, for some devices, for some configurations, it shows the arguments given to the processes. You would just go out there on the internet, do SNMP list process command with a public, community string, so it's kind of open to the internet. You don't need to like have a special password or anything, and it would show you stuff like this. So obviously, I mean, there are not like hundreds of thousands of these instances, but people, I think, just in this case, don't realize that this feature is there, right? So they don't pay attention to it. It's just out there, and we need to kind of educate people on how to fix this and that this shouldn't be happening. We shouldn't be able to see this. This goes on and on with other things. One thing is Telnet shells. Like if you connect to the Telnet port on thousands of devices, they don't even give you a login, login prompt. They just give you a shell right away. So you just connect, just do Telnet IP something, and you just are given a prompt, and then you can check what user you are. Same thing happens on some Windows CE Telnet services, so you get like Windows CMD shells, but you get even root shells on some devices, on some routers, switches, whatever it is. And this is really, really weird. Like, right, why would it be in there? Is it, intended? Is it just misconfigured? I mean, what is happening to those devices? Like sometimes we didn't really understand what was going on because it doesn't make any sense. So this is what you find when you just go out there, collect data, just look at it, right? You don't even need to do any reverse engineering or anything. You just find sort of the problems and the vulnerabilities. Telnet other stuff, we found license plate readers and GPS tracking devices. So, there would be like lines and messages coming up, like we connect to it and just give us like all the cars driving by at a street, at a highway somewhere. So it's like, you don't really understand what this is. It might not be a security problem. That is up to the actual application or dependent from case to case. But of course, this is, we're curious and this is weird to us. This looks, I don't know, strange. There was other research that we published on so-called serial port servers, which essentially on one end have a serial port. On the other end, they have like a network cable, a Wi-Fi antenna, or like even a 3G slot or SIM card. And you basically connect it to your server rack in your data center or something, and then you can configure it remotely from home, which is convenient, nice. The problem is it's in a lot of cases misconfigured. These things have default passwords, and sometimes they don't even ask for a password. They just directly patch you through. So if you connect it to the serial port, the assumption is you're physically there, so you have access to the device, and you also have the authorization to the device, right? But if this thing passes you through, like without adding some other authentication layer, then you're just, as if you're next to the server. So this is something that we found, lots of devices that are just exposing shells or configuration interfaces. Here are some examples of that. So like we found some fuel control systems, fuel pumps that would have their configuration interface, public. You just connect to a Telnet port or something else and just offers it to you. Traffic light controls, IPTV systems. There was a points of sales device from a dry cleaning shop. You could check out who cleans their leather jackets in that shop. I don't know. I mean, this is, you might say, well, dry cleaning shop, whatever. It's not, it's not a big deal. But I think it's not about the individual case. It's about the overall problem of this, right? I mean, the awareness or the knowledge about what it means to connect one of these devices to your local serial port is not there, and it's, you need to try to educate people on this. All right, so let's get back from like the kind of ancient historic stuff like serial ports to something very recent and very up to date. ElasticSearch is a search server, so to speak. It's like a little bit of it's like a database, but it's basically used for enabling search functions on forums, on websites, and so on. And this is really interesting because if you do like development with ElasticSearch, or you have like a staging server somewhere, and it maybe has not confidential data, and you think this is okay, I just use it from home, it's a temporary instance or something. You just put it on Amazon instance, or just put it out somewhere and just open and you use it from home. Now, okay, the data in there might not be that interesting, but by default, it allowed so-called dynamic scripting, where you could essentially just execute code on the server. I mean, this is a feature of ElasticSearch. So you just upload Java or JavaScript code and just runs it. So essentially, you think you put up a database and you just use it from home or on the public internet. You want to look into the data, issue like normal API calls, but it's essentially just a shell, right? I mean, it's just code execution on a public port. So this is something similar, like where you don't really realize what the actual implications of this are to put this on a public IP. Yeah, it's not the only example. It's the same for MongoDB and other NoSQL, SQLDBs without auth or default passwords. Okay, so this all led up to, this research led up to us starting this project called Sonar. And it's basically trying to do this sort of internet data gathering, this large-scale data gathering on a continuous, basis, on ongoing basis, and we are trying to publish all the data and raise awareness about the problems and find more of these issues, regularly, and not only do a project once, go to a talk, present some vulnerabilities and then stop, but we want to do this as kind of a community project. We want to, have this ongoing and hopefully for the next years. It's been running now, I think, for like 9 months or so. It was announced at DerbyCon in 2013. Okay, so just a quick overview of what is currently in there. We plan to extend this, but we started out by collecting SSL certificates from the internet. Then we added an HTTP GET / against every IP address where we find a web server on. And we grab the data, we grab the index page, the HTML that comes back, the server headers, and so on, and then we publish the data. Same for reverse DNS, so we do a bi-weekly reverse DNS lookup on every IPv4 IP address. Just put it out there. Might not be that interesting, immediately to you, but if you like combine certain data sets and if you look into it, there are definitely some interesting use cases for this sort of data set. We do forward DNS lookups as well. We compile like a huge name list and basically say, give me like what is the IP address behind that name, or we actually do any lookups, which is essentially saying, give me a couple of records, it doesn't matter which type. And yeah, we have like, millions and millions of these records, and it's all published, of course. Some of this is actually, like the forward DNS data set, I think it's not automatically published, so I need to get back on that. Okay, we do other SSL certificate sources, not only the web server, but we also look at mail servers, IMAP and SMTP and so on, and we are adding like more things along the way. And this, again, this stuff is used for research internally, but also we publish the data so that anyone here can hopefully use it for some research. We added recently several UDP probes. So we added probes for UPnP, IPMI, NTP with the monlist command, NetBIOS, a couple of other ones, and it has proven to be very interesting to do that and to see like what versions are in use out there. And I'm going to get into some of these examples now. Just to give you a feeling of what this means in terms of data sizes and amount of devices that are out there. For 443, so HTTPS, we find about 40 million open ports, roughly 25 million SSL certs in use at the same time, and this is because a lot of the big, large hosters and Cloudflare and so on, they have basically 1 million of IPs with the same SSL cert. So it's a bit less than open ports, and it's roughly 55 gigabytes of data collected in a little bit less than 4 hours, and we do this every week, right? And then it's reduced and kind of made up for, or like processed and then uploaded and published. Yeah, for HTTP it's a little bit bigger. We grab like the HTTP index page, results in like a bi-weekly data set of 220, 230, 40 gigabytes, and roughly 60, 65 million web servers are in this data set for every 2 weeks. Reverse DNS, more records, less data. So it's less data again than HTTP, but of course it's on reverse DNS. Around 1.1 billion devices or IP addresses have a reverse DNS record associated with them. All right, let's continue a little bit into the recent findings because I got to be fast today. So recently, one of our guys, John Hart, he looked at network address translation port mapping, which is called NAT-PMP. It's a protocol that is it maintains port mappings on NAT devices. So typically used to control or enable certain software or devices to talk to others on the internet, map ports from the outside back. So I think this was used for voice over IP or Skype, some other protocols. And over 1 million of devices expose this service on public addresses on the internet. And this is, our assumption or our understanding of this is used for internal networks, like from the inside, to control how the network address translation operates and change its behavior, add some port mappings. But it's actually exposed on 1 million devices to the internet, so you can use the service from here, right? You can use it remotely, which is interesting because it's not really meant for that, and it's either on these devices probably deployed incorrectly, it's some misconfiguration, or it's more likely that they just suffer from vulnerabilities in the implementation. They're just available even though they shouldn't be, right? And this allows you basically to open ports from the outside to all kinds of internal devices behind the router, which you think normally is kind of a firewall for you, right? It doesn't allow people from the internet to reach your local iPhone. But actually, due to NAT-PMP, we can sort of, this is a problem because you can actually reach it. So yeah, so this is one of the things. This is still ongoing research. I don't believe we have a white paper on this one out yet, but yeah, it's sort of ongoing and it's really interesting, and we're kind of putting it together in a nice form for you to also look at then. MS SQL is another one. Microsoft SQL Server has this UDP port where it gives you metadata about the database server, such as is it a clustered instance? Is it a single instance? What kind of version is it running? So we send a probe to this port and we get all the version information about these servers. And if you then map that to the vulnerabilities that are known about Microsoft SQL, you will find that there are 10,000 to up to 40,000 of Microsoft SQL servers that have just CVE identifiers basically for that particular version, and they're just in use and they're on public internet ports, right? So most of these will be immediately compromisable if you use something like Metasploit or something else, which is an issue, right? This shouldn't be out there anymore, and especially not for CVEs from 2011. If someone didn't patch their UPnP from last year, okay, maybe it's maybe they didn't pay attention to it, but this is really old kind of deployments, and this shouldn't be out there anymore. And I feel bad when I see that this is we see this so often in our data sets. I looked a little bit at DNS names. This is probably not so interesting. It's not really a vulnerability, but it gives you a picture of what happens or what you look at when you look at this data. You collect data and you look into the actual content, into the traffic that you get, into the data that you get, and it's just weird sometimes. Like there are DNS records that don't use the format that is normally defined in the RFC or something for the server record, for example. SRV record. So it's probably hard to read. I shouldn't have used this font here, but yeah, there are just thousands and thousands of these records, and they are not really usable, at least by the standard implementation of clients. So I'm wondering, what is this? Is it a special proprietary protocol? Why do they put it in this record? And it's just sometimes weird, and I hope for some of your ideas on what this stuff means, or for example, why there are Hinfo. Why are there 750,000 records in our data set? And that is not all, right? It's not exhaustive. It's just our view that we had in our data. Why are there 750,000 host info records that tell you something like this is an IBM PC and it runs Linux? Why is that in a DNS record? I don't understand. What is it used for? Is it used for nowadays by some application? I don't know what it is. Lots of location records where there's basically a GPS location assigned with a domain name. I didn't really know that existed. I don't even know what it's used for. Oh, I'm over time already? No. Yes? Okay. I didn't notice that. All right. So basically there are a couple of other ones on these. I need to finish up, but The point is, yeah, we have NTP Monlist was another one. We also collect data on that one. There are recently, I found remote code execution bugs on more DVR systems that record basically video streams and video streams from cameras. So there are just many more of these findings, these problems out there, and we basically need to change the way that we look at this data, and we need to improve on fixing and actually patching our systems. I mean, you know this for embedded systems, but it's not only true for embedded systems. All right, let's go. Let's skip the live demo. If any of you guys want a live demo on our data and look into it, come to me afterwards, and we get that done. Sorry about that. The data is on scans.io, this URL here. Check out the slide set. Visit the webpage. You can just go to the website, download the raw data sets, and we'll soon also have an API and kind of a lookup, a search interface. All right, this is how it looks like. Doesn't matter. So the internet is broken. This is my summary slide. Yeah, we need to tackle this a bit better, and we hope that our scanning and our data is one of the tools to actually tackle that problem and actually hopefully improve a little bit on the scale that we're fixing things. All right? So yeah, the ZMAP guys, a couple of references, and then thanks for listening. If you have any questions, if you want to check out the data, please come to me afterwards.